So let's start with the question. B. Shrink. A shrink operation on an array A of size m is defined as follows. We choose an index I which is less than equal to m minus 1, size is m, and greater than equal to 2, such that a of I is greater than a of I minus 1 and a of I is greater than a of I plus 1. So we have to define the score of permutation P as the maximum number of times that you can perform the shrink operation of P. Yusuf has given you a single integer n. Construct a permutation P of length n with maximum possible score. If there are multiple answers, you can output any of them. So what the question is saying here is that we have an array and we can perform a shrink operation on that array. So what is the shrink operation? Like if this is your array, it's 1, 2 and 1. So we can do a shrink operation on an element such that we choose an index 2 up till size minus 1. Okay, so we cannot take the first and the last values. Okay. This is at first position, this is at second position, and this is at third position. So we can choose an index that lies in this range, and we can check if it is greater than its previous element and its next element. If so, then we can shrink it and we can remove this element and the array will become this after removing the element. So we have to give a permutation of the array so that maximum number of shrink operations can be made on that array. Okay, so the array will contain the numbers 1 till n, the n that is entered, and we have to create an array that will perform the maximum possible shrink operations. Okay, so let's understand it from the test case. N value here is 3. We are given n is equals to 3. So we have elements 1, 2 and 3. Taking these elements, we have to create a permutation of that array that will give the maximum possible score. So we can create this array like this. We can keep 3 here. We can keep 1 here and we can keep 2 here. So only one operation can be made because the first and the last elements are not to be removed. So only one operation can be made. The array can also be 2, 3 and 1. So we can remove this element, the second element, and the array will become 2 and 1. So only one maximum operation can be made here. If we see the second test case, that is 6. Okay, so we can see here that the elements are 2, 3, 6, 4 5 and 1. Okay, so how many possible shrink operations can be done? First let us shrink this, then the array becomes 2, 3, 6, 4 and 1. Then we remove this and we shrink the array further, then the array becomes 2, 3, 4 and 1. Next we remove 4 from here, we have 2, 3 and 1, and next we remove 3 from here, we have 2 and 1. So what are the maximum number of operations possible? It is 1, 2, 3 and 4. So this is only example output. We can output any permutation. Okay, so we can solve it like this. Let's make an array that has 6 elements. Let's fill the first position with 2. Fill 2 here. Let's fill the last position with 1. Okay. Next, at the middle position, at n by 2th position, that is 6 by 2 here, that is 3rd position, we will fill n itself. Okay, so now we have positions 4 left, 5 left, and we have position 2 left. Let's take a temp element that is equal to n minus 1, that is 5, and let's fill these positions that are forward of n by 2th position. Let's fill 5 here, then we decrement it and we make it 4. We fill the next position with 4. We stop here because all the second half positions are filled. Next, let's fill the remaining positions with the left value of temp. Okay, so what is the value left? It's 3. Let's fill here. Let's check if the maximum number of operations we do on this array is 4 or not. So the array is 2, 3, 6, 5, 4 and 1. First we remove 6 from here, that is 1. The array becomes 2, 3, 5, 4, 1. Then we remove element 5 from here, we have 2, 3, 4, 1. Then we remove 4 because the previous element and the next element both are smaller. Then we remove 3. How many operations are there? 1, 2, 3 and 4. So basically we have to make an array where the majority of greater number are filled in the right half of the array and the rest of the numbers are filled in the first half of the array. No matter which value of n you take, the array that is formed will have the maximum number of shrink operations. You can check that with n is equals to 7 also, and comment below what value, maximum value do you get for n is equals to 7 following these steps. Okay, so what do we have to do? First, fill the first position with 2. Fill the last position, that is nth position, with 1. Fill the middle position, n by 2th position, with n, right? Fill right half of the array with left elements, the elements which are left elements in decreasing order, and fill rest elements, fill rest in increasing order. Let me explain this point. Like when we were filling here, so we have to decrement the value of t and keep on filling here. First this position will be filled, then the next position, then the next position, and then the next position. And here first we have to fill the RHS with the positions t. Here it will be filled in the decreasing order, right? And here, as we see from left to right, it will be filled in increasing order. Okay, so that's how we have to fill it. So let's see the code for this question. We have a vector A, we have input n, we fill the 0th position with 2, we fill the last position with 1, we fill the middle position with n, we declare temp is equals to n minus 1. We start from the n minus 2 plus 1, filling the RHS, in decreasing order. Here we fill the RHS in decreasing order, temp minus minus, and I plus plus positions are increasing until it reaches the last element. It stops at the last element because we have already filled it with 1. Next, we fill the LHS. We stop when I reaches the 0th position. We start from the position n minus 2, n by 2 minus 1. We fill the positions and decrement the value of I. And thus we get the array A, that is the permutation with maximum number of shrink operations. So I hope you understood the solution of this problem. So thank you.